Okay, we're still on the 2-1 to 2-5 review. Calculators are not allowed yet, and this is number 6. On all 3 of them, we are going to determine whether the statements regarding them are true or false. So, each of these 3 is a piecewise function, and all of the statements are determining whether or not we have outputs at the joint, outputs at the joint, outputs at the joint. Then it wants to know whether the limit exists at the joint, at the joint, at the joint. And then based on the answers from these 2, we can determine whether or not f is continuous at that joint. So let's recall that f is continuous at x equals a if and only if the limit as x approaches a on f not only exists, but it also equals the output of the function at a. So on all 3 of these, we're not going to have continuity unless the first thing that occurs is that we have an output. So to determine whether f of 0 exists or not, we have to look at the branches to see if 0 is ever viable input. Here we can see that x equals 0, so if I plug in 0, then a 3 is going to come out. So f of 0 equals 3, and this is a true statement. Same thing with this one. If I want x or the input to be -5, then I look for the branch that corresponds to that -5, and then I see what comes out. It turns out that f of -5 is -5. So again, that statement is true. If I move to my third one, f of 0 means I want to plug in a 0, so I look for the branch that uses 0, and it's right here. The output is 6. So f of 0 equals 6, and the statement is true. All 3 of them have outputs at the joint. So now let's look at part 2, which is a little more tricky. Because we are approaching a joint, we have to examine both the left and the right hand limits. So I will do A longhand, and then I'll show you the quick and dirty method to do B and C. I want the limit as x approaches 0, so I'm going to come at it from the right and from the left. Notice that if I'm bigger than 0 or if I'm smaller than 0, neither of these are going to be at 0, so both of these will be used with this top branch, because I can be less than 0 or bigger than 0 with this branch. So I've got an x squared plus a 3x over an x squared for the limit coming from the right, and I have an x squared plus a 3x over an x squared for the limit coming from the left. Now, if I plug in 0 right now, we can see that I get a 0 on the top and a 0 on the bottom. So usually that's evidence of a hole. So let's see if we can fix it. When I do that, I am going to factor the top and see if I can eliminate the issue that's causing me trouble on the bottom. When I do that, I can only get rid of one of those x's on the bottom. So now if I try to substitute in again, notice that I get a positive 3 over a 0. That's a number over a 0. So it turns out we don't have a hole, we actually have an asymptote. As soon as we get a number over a 0, we're going to have an asymptote. Because it's an asymptote, I'm interested only in the sign. So as I approach 0 from the right-hand side, the top will be positive and the bottom will be positive. So I'm heading toward infinity. Now let's look at this side. Coming from the left, I'm still in the same branch. I'm still going to try and fix it the same way by factoring. I'm still only going to be able to get rid of one of those x's on the bottom. And we're going to see that not only do we have an asymptote coming from the right, but we also have that same asymptote coming from the left. Only now when I plug in a number that is smaller than 0, the top is still positive and the bottom is negative. So coming from the left, I'm heading down. These two do not match, so that means that the limit does not exist. So that statement would be false. Now in order to be continuous, not only does the limit have to exist, but it also has to equal the output. So looking at part A, I don't have a limit existing, so no way could it equal the output of that function. So 3 is false as well. So now let's look at B. And I'll get a spare piece of paper here. If we look at B, we want to determine whether that limit at f of 5 exists. So I'm going to scoot this up a little so we can see. Again, or excuse me, limit at -5. Again, we're looking at the joint. So we're going to examine the limit as we approach that -5 from the right and as we approach that -5 from the left. Both of them, coming from the left and coming from the right, are going to be in this branch because neither from the right nor from the left are we actually at -5. So on both of these, I will input the top branch. Now if I try direct substitution, which is my first line of defense, plug it in, I get a 0 on the bottom and a 0 on the top. So it might be a hole. Let's see if we can fix it. In order to fix it, we factor the top, and what do you know, that factor that was causing us grief cancels, and now I can do direct substitution and get the limit as x approaches -5 from the right of just an x will give me -5. If I repeat the process here coming from the left, I'm going to end up with the exact same thing. And that's good news for me because that means I got the same limit coming from the left as I did from the right. Sorry, that should be a minus, which is -5. These two match, so that means the limit as I'm approaching that joint on the function was -5. So item 2 is true. The last thing we have to check is item 3. Is f continuous? Well, in order for f to be continuous at x equals -5, the limit as I was approaching -5 would have to equal the output when I plugged -5 in. So here my output was -5 and my limit was -5. They're the same, so this one is also true. Third and final one, part C. We want the limit as x approaches 0 from both sides. 0 is the joint, so we're going to come at it from the right and we're going to come at it from the left. Notice that both of them use the same branch, just like before. So I'm going to factor while I'm at it. And notice that I can get rid of that x. So now the problem factor is no longer in effect, and I can plug the 0 in. Both of them give me a 7, which means the two-sided limit of that function is equal to 7. So the limit does exist. It's 7. This is true. To check continuity, I need that limit as I'm approaching 0 on f of x to be the same as the output of the function at the point I'm approaching. So up here I had f of 0 equals 6, and here I have my limit equals 7. So I am not going to be continuous, and that is false.